Alright, it's February 19th, 2020. We're looking at the notes, example 7. There are 8 females and 5 males trying out for the spring play, which has 4 female roles and 3 male roles. How many possible casts are there? Let's see, so there are 8 females vying for 4 female roles, and there are 5 males going for 3 male roles. So first I would say, okay, we got to pick 4 females. And that's going to go 8, 7, 6, 5. And so times I have to pick 3 males from a choice of 5. So 5, 4, 3. So what we end up here with is permutation of 8 choose 4, and so times the permutation of 5 choose 3. And each of these separately will give you the following values for a total of 100,800 total casts. Example 8. A committee has 8 members, 5 women, and 3 men. How many ways can a president, vice president, and secretary be assigned so that both men and women are given assignments? First, let's know that there are 5 women, 3 men, and there is a president, vice president, and a secretary. The only stipulation that we have to obey is that both men and women must be given an assignment. So that's either going to be 2 women and 1 male, or 2 male and 1 female, or 1 woman. If you think of other combinations of this, like let's say you have 3 men, well then you have no women. There's no representation there for women. So the only thing I would add to this is, since we said or, we're going to add. And then you have to think of this other situation. So we could either have man, man, woman, or we could have, let's go back and change this to be woman, woman, man. Okay, and I'll try to color code as I go. So I'm going to let the women have the 5 and be blue. I'm going to let the men have the 3 and be red. So if we have a man, there's choice of 3, and then 2. And if we talk about the women, choice of 5, but then this would have to dwindle down to 4. Now, the way I've lined this up, let's look at this first scenario. This means the man has to be the secretary. So we have to think of the other possibilities of, well, the man could be the vice president, or the man could be the president. That's 3, using our trick yesterday. We could cycle where that man's going to be. What you end up with is 5, 4, 3, 5, 3, 4, and 3, 5, 4. So I'm just going to multiply that by 3, and that's quicker than adding it 3 times together. Same over here. You could have a mixture of where the woman's going to be. So we're going to say there could also be 3 ways that goes too. And when we multiply all this together, we get 180 and we get 90. And since we're adding here, because we could have this with 2 women or 2 men, we get a total of 270. Example 9. A group of 6 students, including Vanna, so that's 6 students including Vanna, not 7 students, has been working on a research project for a course. The project has been completed and the report is to be written. The report consists of an intro, 2 chapters, and a conclusion, a total of 4 sections. How many ways can the students divide up the task by writing the report if each section is to be written by a different student? Right. Simple enough. I'm going to use event blanks and say there needs to be an intro, chapter 1, chapter 2, and a conclusion. Okay? There's 6 people to do this, and there has to be a different person each time, so we'll do 6, 5, 4, 3, which is the same as permutation of 6, choose 4, for a total of 360. Part B. In how many different ways can the students divide up the reporting if each section is to be written by a different student and Vanna writes the conclusion? Okay, so Vanna has to do the conclusion. We also got chapter 1, chapter 2, and the intro. So let's say Vanna does this one. Well, that only gives us one choice. So, like I said before, if we determine what is different, then we can figure out that difference from the total. And what's different is, since we've already selected one person, now what's going to go down is we have 5 choices for the intro, 4 choices for the chapter 1, and 3 choices here. Now you might say, well, why isn't it 6, 5, 4, 1? Well, if you let Vanna be here while still letting 6 people be chosen from here, you're including Vanna in that first selection. So to avoid that, we include her first. Okay, there's your change. And then we have 5 selections, 4 selections, 3 selections for a total of 60. Example 10. 6 students, including Joe, so 6 total, are planning a trip to attend a concert in Chicago. 3 of these students are assigned the task of arranging for a hotel, getting a new Chicago map, and purchasing a concert ticket. So that's hotel, map, and concert. The next part says, in how many different ways can the 3 students be assigned these tasks if Joe is not assigned the task of getting the map? So this is a little bit different. We're saying now Joe isn't the one getting it, but is not getting the map. So let's go to the map and say, okay, if there's 6 students that can do the map, there's only 5 to choose from now because we took Joe out of it. Then we go to the next part. If we figure out how many can do the hotel, well, even though we only have 5 to choose from here, but once you chose one, you would still have 5 remaining to go for the hotel. Joe is one of those 5. And then you could have a step-down multiplication of 4, kind of like 5, 4, 3, 2, 1, but the 5 and 4 kind of skip each other. Okay, so this multiplies out to be an easy 100.